series. An angle of elevation of the top of a tower from a point on the ground, which is 30 meters away from the foot of the tower, is 30 degrees. Find the height of the tower. In such cases, if you draw the diagram correct, that means your interpretation of the given information is correct. So let's proceed. Since we have been talking about the tower, we will be representing that with a straight line, vertical straight line, which will be at an angle of 90 degrees with the ground. And they are talking about angle of elevation, which is always with reference to your eyesight or with reference to ground. So we'll be representing ground with a horizontal line and tower with a vertical line at an angle of 90 degrees. And the eyesight angle, which is the angle of elevation, will be shown with reference to ground. So let's see how the diagram will look like. Here, this vertical line will represent the tower, which is at an angle of 90 degrees. The height is unknown, so we'll call it as h. The longest side is always hypotenuse, opposite to the right angle, and this represents ground. Now let's see what is given and what is required. 30 meters away from the foot of the tower. Now, if this is the tower, then this will be the foot of the tower. And the person who is looking at the top of the tower, this is the top of the tower, and the person is somewhere here. That person itself, himself or herself, is 30 meters away from the foot of the tower. That distance will be measured along the ground. So in this case, this angle is 30 degrees. Remember, angle of elevation will be towards the sky or upwards, and other possibilities also there. Angle of depression in case if you're standing on the top of a mountain or top of the tower and looking downwards. But here they have given us angle of elevation. So this is the 30-degree angle of elevation. So now the triangle is well defined. Let's see what is given. In this case, for this 30 degrees, the side which is directly facing opposite, it's opposite. So that's unknown, h. And the adjacent side, which is the last remaining side, is given as 30 meters. So the question arises, which trigonometric ratio you are going to use? In this case, we want the opposite, and we have been given adjacent. So we care about opposite and adjacent. So the ratio, in this case, we don't care about hypotenuse. So the ratio, the trigonometric ratio, which correlates opposite and tangent. So we can write a generic equation, tangent of theta, which is a Greek alphabet for representation of angle, generic angle, any angle, is opposite over adjacent. So in this case, we can write particularly for this scenario, we can write tan of 30 degrees is opposite, which is h, and adjacent, which is 30 meters. Now, tan of 30 degrees is a standard trigonometric value. If you have not studied the table of standard trigonometric ratios of some specific, it's a good time to revise them. Tan of 30 degrees is always 1 over root 3. So that will be substituted in place of tan 30 degrees. And now it's a question of algebraic manipulation. We can take this 30 on the other side. So h is equal to 30 times 1 over root 3. So the answer technically is 30 divided by root 3. Even though this is a technically correct answer, we prefer not to keep the denominator as an irrational number, square root of 3. So we will multiply and divide both numerators and denominators by root 3. In that case, root 3 will become 3, and this numerator will become 30 root 3. And this 30 can cancel this 3. So eventually you will have 10 root 3, and the units will be meters.